Hello, my name is Mohamed Osama. Let me introduce to you our DSD project, which is a clock with alarm in it. Our clock in this project is a real life project, is a real life clock, which the user can set it with hours and minutes of his choice. Also, the user can do the same thing with the alarm, but this is not usual alarm. Our alarm has certain requirements in order to turn it off. We must make sure that the user is already awake and alerted by using sensors in our project. Now I will leave you with my colleague Karim Amir to introduce to you our sensors in this project.
In our project, we have two input sensors. The first input sensor is the light sensor, which is two channels light sensor, which ensure that the user wakes up and turns on the light. If the light is off, you will see the green light is not turned on, and if it detects light, it will be on. This is a proximity sensor which ensures that the user is standing in front of the alarm to raise his alertness. And this is a buzzer which is connected to the GPIO that produces a noisy sound to ensure that the user wakes up and is alerted. And now I leave you my colleague Amr Ahmed to set the clock.
Hello, so I'm gonna start now our project from my laptop, which is connected to the FPGA. I'm gonna start it. And now, as you can see, once the project starts, the clock will be generated automatically, starting from 12 a.m., which is the default value. Our clock has many features, such as resetting the clock to its default value, or setting it again to our desired values. This is the switch for entering the time setting state, which is slide switch number 1. We have slide switch number 2 for incrementing the minutes to your desired minutes, and slide switch number 3 for incrementing the hours. And once we push this slide down, the clock will be generated again. So now, after we have set the time, now I'm gonna show you how to set an alarm for this clock. So I'm gonna reset back the time to its default value, then I'm gonna set it to 1 hour and 1 minute. Okay, and now the clock is generated again. So we switch on the alarm setting to from slide switch number 4. So now these values are back to 0, so I can set my alarm. I'm gonna increment the hours to be 1 and the minutes to be 1, so it meets our current time and start automatically. So again, from incrementing the minutes, sorry, I incremented it to 2, so I'm gonna set the time back to 2. And now it's 2 hours and 2 minutes. So I'm gonna set the time to 2 hours and 2 minutes. And now once I push this slide down, the time will meet the current time and the alarm will go on. After the alarm goes on, we will have to meet the 3 requirements of the light sensor to be on, the proximity sensor to be on, and solving this math equation which will be generated after the alarm is set on. The equation is a simple math equation of 2 numbers with the plus operator. As you can see now, the buzzer has started, and this is the equation that I should solve. I start solving by switching slide number 5, and now I'm gonna increment the tenths to 3 and the units to 1. Okay, so now the light sensor is off. Once I let it go and detects light, and the proximity sensor is detecting my motion, and the slide this switch down. So now the alarm clock is turned off, and the time resumes after the alarm is set off to the current time. So now this is a one-time alarm. I will leave you with my colleague Hazem Hasib to show you how you can set another alarm, which will has.
Hi. In order to set another alarm, we have to set this switch to reset the alarm. we have to reset it to set it on, and 0 switch it back to 0. And then I will set an alarm at 12 a.m. our default value. So the clock now at our default value, and now I will set the alarm 12. So and now as you can see, there is another equation generated by turning off switch 5 as the previous example. The answer will be 23. And the sensor detects me, and the sensor already detects me, and the light sensor is already exposed to the light, so the alarm turned off. And as you can see, this sums up our project. Thank you.
In the previous part of the video, my teammates explained how the project works hardware-wise. In this part, my colleague Mohammed Musa and I, Karim Ismail, will describe how the project works software-wise. The code of the project is divided into 15 parts. The first part is for the clock generating for incrementing the seconds every second. Second part is for handling the using of reset switch slide, which resets all the clock values and the alarm values. Third part is for handling the using of reset alarm switch slide, which only resets alarm values to zeros for setting a new alarm. Fourth part is where the clock is generated if no switches are used. Outs is incremented by 1 if it is not equal to 59. If it reaches 59 seconds, it will be set to zeros, and so on for minutes and hours. Fifth part is for setting the clock to its previous values before the alarm switch is switched on. Then there is a flag which is set to 0, so the clock will be only set once to the temporary values. There is another flag which is to indicate that an alarm is set. Sixth part is where we check for the input sensors and the solving of the equation. There is a flag for the alarm is set correctly. And another one is where we check if the infrared to be on by inverting its signal, checking if it's equal to 0. And there is a light sensitivity sensor which checks the same as the infrared. Then we check if the temporary value is set to the solving of the equation, which is tens value, which the users enter. And also the users enter the units for the solved value. A value is calculated as the tens plus the units for checking of the math equation. Seventh part is for setting the clock whenever the switch is on. The clock stops generating and you decide the hours and the minutes of the new clock. Eighth part is for setting the clock whenever the switch is on for setting the alarm. Works the same way as the time set, but after turning off the clock is back to its original value. Now I will leave you to my colleague Mohammed Musa to explain the remaining part of the software.
Now I will continue explaining the remaining part of the code. Number 9, for when the solve switch is opened, which sets the solving flag to 1 and adds the options of incrementing the tens and units by the hour. Part number 10, there is an always block that sets the left two most 7-segment display to be off until the alarm is activated. It opens them and gives them the value for the first number using the flag buzz, which is only 1 when the buzzer is active, and set back to 0 once the buzzer is turned off, setting back the 7-segment display to the usual clock settings. Part number 11, same as the previous mentioned always block, it sets the hours part to the second number when the alarm is set on and the buzzer is on. Goes back to showing regular clock after the buzzer is off. Part number 12 is also same as the above two mentioned always blocks, but the difference, it sets the minutes part to BL, meaning plus operator, and back when buzzer is off. Part number 13 gives the space for the user to solve the math equation instead of showing seconds once the buzzer is on. And part number 14 The following tasks are for displaying the clock for the desired values on the 7-segment display of the FPGA. First task is dividing the number into BCD from 1 to 9, and second task translate it onto the 7-segment display, and so on for the rest of them. And last but not least, part number 15, which is for generating the BL sign. Thank you.